Good morning, Griffins. This video is going to cover exponential equations, plug and solve. The handout, it is in my classroom if you would like to come pick it up. But you do have to watch this video on your own. If you were not in class during the third or fourth period on Monday, April 11th, because it is a C day, and I know some of you freshmen are testing. However, I think that if you watch these problems, you will get a better idea of how to solve the problems on the homework. And also, we're going to cover 4 more once you guys are all back in class. So we start with the first one. We have a piece of paper. It's about 0.004 inches thick. If you fold the paper in half, and so just pretend you have a regular sheet of paper, you fold it in half, then the height of the paper will double, as you can see here. So it will be twice as just the regular height, not height, but thickness of the paper. Now, if you fold it in half again, it will be twice the amount of the previous one. So this one times 2, and so on. So every time you fold it, the thickness of the paper will increase by 2, okay? So if we keep doing that, they do have a model right here. And I want to point out to this 0.004 is actually the original thickness of the paper. Kind of like what we're starting with. And the 2 to the x is representing that every time you fold it is going to increase the height by 2. And so if you don't fold it at all, it's like you're finding the thickness when the paper is not folded. So it will just be 0.004 times 2 to the power 0. We know that 2 to the power 0 is just equal to 1. So it makes sense that we get the original thickness, right? And if we fold it one time, we will get 0.004 times 2 to the power 1, and so that's how we get the 0.004 times 2, and that's how we get the 0.008. Now, let's look at the questions and see. It says here, determine the thickness of the paper after 8 folds. So what we're going to find is the thickness after folding the paper 8 times. So we're going to use the equation given to us. We have 0.004 times 2 to the power x. And actually, I'm already saying t of 8, so I'm going to substitute my exponent with the number 8. And this will be 0.004, 2 to the 8th power. I'm not sure what it is. Let's see. 256. 256? Thank you, Simone. And so we'll go ahead and multiply that times 0.004. What do we get? 1.024. 024. And remember, the units here are inches. So if you think about it, that's kind of thick, right? We're talking about, 1 inch. So from 0 to 1 inch. So that would be pretty thick. If you fold it 8 times. Now, the next question, it's about the same problem, same equation. Oh, let's go ahead and write the units. Now, part B, it says here, set up and solve an equation to determine about how many folds it will require to make a stack 11 feet tall. Now, this is a little unrealistic to me, but I don't know, maybe one day I will fold the paper those many times. So if you notice here, we started with inches, now we're talking about feet. So before we do anything, we need to convert 11 feet. We need to convert that to inches. And so we need to know how many inches will be there. What I know is, well, hold on. What I know is that 1 foot is equal to 12 inches, right? Is that correct? Okay. And so what do you get, Samantha?
I got 132 inches.
132 inches, and you got that by doing?
12
times 2. Very good. So we get 132 inches. So the question is, set up an equation. So we're going by the main one, which was this. And now we want this thickness to be 132 inches. So now we need to find how many folds. So we're trying to, right here, we're trying to find x when the thickness, when T of x is equal to 132 inches, all right? So for here, we're gonna try to solve for x. So the first thing we need to do is take that 132 and divide by 0.004. Why do I say divide? Because the 0.04 is multiplying to the 2. So can you guys tell me what that is, please?
It's 33,300.
You know what, actually,
33,000.
so that we don't have to round too much, let's just leave it like that. And then from here, we could do several things. We could take the natural log on both sides. Like that. And then we could use that power property that says the exponent becomes the coefficient. So then we have x times the natural log of 2. Now, to solve for x, you could see that x is multiplying to all this, right? The natural log of 2. So to find it, we could simply do a ratio of the natural log of 132 over 0.004 and then divide it by the natural log of 2. We do that because if we were to do that on both sides, it will cancel here, right? So that's the idea of that. You can find x by doing this. Natural log of 132.004 divided by the natural log of 2. So can you guys do that for me, please? And let's approximate. Does it say, we're talking about folds, so let's approximate to the integer. Yes. And remember, you need to have natural log in both numerator and denominator. You got something? Fine.
I got 15.0.
15.01. So let's go ahead and round it to 15. So 15 volts. Do we all agree?
Yes.
Yeah? All right, perfect. So that means that if we were to fold the paper 15 times, we would get that. And it just seems like a little unrealistic to me, like I told you, but maybe we should try it one time. Let's see. I really want to try it. Okay. So let's go to the next problem. So now if you notice here, we did two things. First, they give us x, the number of folds, and we had to find the thickness of the paper. And then the second question, they give us the thickness of the paper, and we had to find how many folds, right? So we worked the problem two different ways. Now the next problem, we have a game system, and it says when a new game system first came out, it cost $500. Over the next couple of years, however, the price fell by a certain percentage each month. To find the cost, see after m months. So now the months is our independent variable, and the cost will be our dependent variable. All right? So like your m is your x, and your c is your y. That's what you're used to most of the time. So now we have the function. It is given to us. And it says here, how many months did it take before the price of the game system fell to $200? So what we're going to do is take the equation given to us, and we're going, and if you notice right here, the 500, it represents the original price of the game system. And the 0.95, it represents the decreasing in price. So every month, the game is losing 5%. So because of that reason, we have 0.95. So at month 1, it will be, I'm sorry, like when they purchase, which will be month 0, it will be 500. Now, after 1 month, could you guys multiply 500 times 0.95? 475. And so now multiply 475 times 0.95. 451. You see, so every month the game will depreciate in value. Okay. So let's see here. In how many months will the price fell to 200? So now we want this new price to be $200, and what we're going to solve for is for M. So we're going to do like we did the previous one. First, you have to consider 500 is multiplying to the 0.95 to the power M. So we're going to take that across, and then it will be dividing. So we will have 200 divided by 500. Then we have 0.95 to the power M. And one thing we could do here is take the natural log on both sides. That never fails to work. And as long as we do it to both sides, we know we're okay. Then we take the exponent, and I'm going to use the power property here, this one to the front. And that M now is a linear quantity, and it is multiplying the natural log of 0.95. And here I could maybe just reduce this fraction to 2/5 if I want to, but I recommend that you leave it as a fraction. So now lastly, remember we are solving for M. So we know that the natural log of 0.95 is multiplying to M. So if I take that across, it's going to be divided. And so we're going to do the same operation that we did. Natural log of 2/5 divided by the natural log of 0.95. And that will give us M. That will be the exact answer. However, we need an approximation, right? And since we need the number of months, let's approximate to the nearest integer. Now, when you divide, make sure that you do have natural log in both parts, both places, numerator and denominator. So we got 17.86, not 89, sorry. So 17.86. Now, if we had to round to a month, let's look at the question again. How many months did it take before the price of the game system fell to $200? Now, if we were to say 17 months, the price is not going to be at 200 yet. It will be like 200 and something. But so then what we will have to do is round it to the nearest, to the greatest integer. So then we will say it at 18 months. Now, you know that when the price was exactly at 200 was at 17.86. So what that makes me think, actually it is true, at 18 months it's going to be a little below 200. Okay? At 17 is still a little above 200. At 18 months is a little below. Hold on. Above 200. And this will be below 200, slightly. Now, how could you check all this stuff? Well, you could always type in your equation and get a table of values. And you could check what would be the price at 17, what would be the price at 18. Okay? So let's go to the second part of this question. It says, what was the cost of the game after 2 years? So before we do anything, let's convert years to months. And the reason I want to do that is that the problem, it is specified there that they're counting time in months. And it's right here. You guys see? M, months. All right, so we have to consider all those things. So if we have 2 years, how many months are there? 12 for each year.
24.
So 24 months. Now let's see, what is the cost of the game after 2 years? So let's use the same equation. C of M is equal to the original price, 500, times 0.95 to the power M. So now we're finding C of 24, the cost after 24 months. So all you have to do is put it in your calculator. Just make sure that the only thing raised to the 24th power is the 0.95, okay? And not the 500.
It's 140 or 146.
146. Any cents?
Well, it's 145.
0.99.
So it's 1.
All right. And I just say this because we're talking about money, so you know how 99 cents could make a difference, right? Sometimes they make us buy stuff. Because it's $4.99 instead of $5, or $9.99 instead of 10. I always talk about that. Okay, so it kind of makes sense, you know, if you get a brand new game, and then after 2 years of use, yeah, it might drop like that. You guys know what drops even more than video games? Cars.
Really?
Yes, it's ridiculous. By the time you drive with that car out of the car dealership, it's already worth like a lot. Not a lot,
Yeah.
but less. And every day it goes down, down, down. We're gonna do a problem like that pretty soon. All right. Next, last two problems that we're gonna cover. We have one about investment, and it says here we have a formula again. So that formula gives the value in dollars of an investment after T years. And I want to just remind you about this formula that we were looking at last week. And let's see if this one kind of reminds you of it a little bit. So right here, the 5,000 is the money that was invested initially, the one that we used to call the principal, right? And then right here, the capital A is just representing the future value, which here is denoted by B of T. Now, here we have the 1, and the formula says 1.045, but so what I did here is I just split that 1 and the plus 0.05. So you can see that this part here is actually coming from here. Well, if you had to choose the number of compounding periods, what would you say that is? How many T's do we have in the formula? Right here. Only one. There's only one there. This one will just be to indicate like the function notation. So what this means, guys, is that the number of compounding periods, it was just one. Yearly. But it's the same formula, okay? So let's see. How much was invested initially? Oh, we already answered that question. How much was invested initially? Right there.
Yeah.
But let's say if you don't know, you will find it this way. What is B of 0? And if you were to substitute that into the original formula given to us, I'm going to use this one, which is the same thing. And you put a 0 here. What is 1.045 to the power 0? It's just 1. So the amount is 5,000. So remember, when you say initially, you're referring to when time equals 0. Okay? Now, next question. How much will be in the account after 3 years and 6 months? Now, we need to figure out, right here, it says the time is in years. That's important. However, here they're asking us something in years, 3 years and 6 months. Well, we know that 6 months is what in a year? Half the year, right?
Yeah.
Or we could say 0.5.
3.5.
So let's use 3.5, very good. So now we're going to find the future value when the time is equal to 3.5. Okay, go again.
5,832.79.
All right, very good. So, do you guys think that investment pays a lot of money? If you have to pick a rate in a percentage, what would you say? Right here, what we have so far is 0.045. What would that be as a percent?
4.5%.
4.5%. And yeah, that is not a good rate to have on an investment because you're not going to make that much money. However, that realistically, that's a good rate given at this present time, year 2016, or even lower when you want to start a savings account. You'll be surprised. But if you talk about credit cards, well, those interest rates are to the roofs. Yes. So let's move on to the next and last part. And here it says, how long would it take for the investment to be 10,000? Now, I know that Alex's homework has a problem where they ask you something similar. How long would it take for the investment to double? And let's just pretend for a minute that we don't know what the initial amount is. We just don't know. So what I'm going to do is just call it A sub 0. And that means the initial amount, because it is the amount at time 0. And that's what this little subscript represents, okay? So then if the question says, how long would it take for that to double, I will make my future value be 2 times the initial amount. So how can I represent that? With a 2 times A sub 0.
Can you explain what A sub 0 is?
So you know how we used to call A the final amount or the future value?
Yeah.
So then when we use subscripts, we could say something like, what is the amount after 1 month? What is the amount after 2 months? So when we say, what is the amount at 0, that will be the initial amount. And they use this a lot in chemistry. To calculate, to denote like what was there at time 0. Just like the principle here. So it's like the same thing, different notation. So we're just solving this problem without knowing what the initial amount was, but it actually works. It doesn't matter what the amount is. So you could say here, what is the A sub 0? Just think of it as a variable, okay? What is the A sub 0 is doing to the 1.045? Multiplying. So if we take that across, it's going to do what? Divide. So let's do that.
They're going to cancel out.
Correct. So right here, that equals to 1. So we say they cancel, and we just have 2. So now from there, we could do several things. But let's do this just to keep the same style for now. We take the natural log, then we use our power property, move the exponent to the front. And just finally, to solve for m, we will have to divide natural log of 2 divided by natural log of 1.045. And so that will tell us, more or less, how many months it will take. It was a month or years? I think we're all years. We were talking about years. Right. So all this m should have been the t. So how many years? So that was a t for years. So do we have an answer?
I got 15.70.
Very good. Now let's see how many months, since they were talking about months before. And they kind of want to get more specific. So I want you guys to try this. So far we have 15 years. So to your 15.7, subtract 15. Just put minus 15. And then control J. And you should get 0.7 something, right? Okay. Now how many months are in a year? 12. So that fraction, that 0.7 multiplied by 12. Just put times 12. Is that a negative?
Well, I think it's
8.4? Okay, so let's say 8 months. And then that 0.4, subtract 8. You get 0.4, right? Now, we're going to go from months to days. So multiply it by 30.
It's 12.
So that's like super specific, right? And we could keep going to the second, probably. All right, let's go and try to get the last problem done, the fourth one. So this is about population, and we have scientists raise fruit flies in a lab. While they started off with new flies, the population increased rapidly at first. The equation to estimate the population of flies, F, is F of W. So the number of flies is the output. And the input, your independent variable, is the number of weeks. And how do I know it is weeks? Oh, it says right here. Time is in weeks, okay? So W is your independent, or your input, or as you are more used to, your X value, okay? So how many flies did the scientists start with? So we want to find what was the population at time 0, at week 0, okay?
It'll be 500.
Yep. How do you know so quickly?
Because it's, yeah.
Why? Tell me.
Well, because when they started, it just says right there, the initial. It was confused between 450, but.
In the 500.
Yeah, but it said it was. Right, yeah.
Let me see. Oh, I'm writing this wrong. So that is 0.3 W. Okay. So if we were to make W a 0, this will go to a 0, right? And so we will have 2.71828 to the power 0. But then we know that that number to the power 0 is actually equal to 1. So it's like we're multiplying. Right here, we get 1.
Bless you.
Sorry. Okay. So it's like we are multiplying 450 times 1. So 500 minus 450?
50.
So 50. So they actually started with 50.
Okay.
But did the problem start? No. Okay, so let's go to part B. Now, how long would it take for the population to reach 400 flies? So now we already know they started with 50. But we're still just going to go by the equation given to us. So I'm going to write it first. It's 500 minus 450 times. Do you guys recognize this number that I'm writing, 2.71? E. Yeah, that's exactly what it is. Okay, and so right here, first thing I'm going to do is make the future population be 400. Okay, and so first of all, this 500, which is adding, I'm going to take that across, and it will be subtracting. So 400 minus 500 is negative 100. Now, this 450 is multiplying to the 2.71, right? So I'm going to take that across, and it will be divided. So remember, first I took this 500, subtracted from the 400, and then I took this negative 450, because that's how it was on the equation, and I took it across, so it was divided. Now from here, this 2 could turn into positive, so it's like we have 10 over 45. And then here, instead of having 2.71, I'm just going to write the number e. And what I'm going to do here is use the same idea that we were using before. Take the ln, the natural log. As long as we do it to both sides, we're okay. But then here, we could use that property because ln is the base e, so that can cancel out. We just get negative 0.3w. So to solve for w, which is the last thing we're doing, all we got to do is divide the natural log of 10 over 45 divided by negative 0.3. Now make sure you divide by a negative number, okay? And so we're going to get some type of good sound. So we get 5.01. So here I guess we could round to 5 weeks. And that is when the population of flies will be 400. So that's kind of quickly. Okay, so you guys are done. I'm going to pause the video.